delete scoops and the failover, etc. We're gonna do it on next Saturday. So today it's gonna be static routing and the DHCP distribution over that static route. What is this? Okay, so let's share my screen here. Let's talk before configuring anything. Here is my screen coming. Here we go. Okay, so remember guys, when we have a DHCP server, and we have like four requests here happening between the client, any client or and the server DHCP, and we have the request of a discovery, and we have an offer, right? So the discovery is a broadcast that the client gonna send, and after we have an offer, and after we have a request, and after we have an acknowledgement, right? ACK here as an acknowledgement, right? So the discovery is broadcasting. Remember, we have port 67 and 68 that we work with. Okay, so we have a discovery that will be received here, and after the offer will be sent, and this guy gonna receive like hi, I got your SOS message, right? This guy gonna just yell in the network saying that, yeah, I have a PIP, anybody can help me, is there any, I don't have static configuration, is there any DHCP or something like that? We call that packet a discovery packet, right? And it's a broadcast, it's broadcasted, because we don't know what is the IP of a DHCP to be able to contact that DHCP directly, right? So we need a broadcast. Okay, so we need to ask everyone that can receive our message, right? It's kind of an SOS message. Hi, help me, please. Anybody can help me? I'm looking for a DHCP here around, if there is any DHCP, because he don't know yet the address of the DHCP, or even if there is a DHCP, you don't know it yet, right? So he will send a discovery packet. He's gonna discover, say, like, is there a DHCP here, something, right? This gonna be a broadcast, since we don't have a choice because we don't know the DHCP server. So the client is programmed to broadcast that packet, right? So it's a broadcast. Keep it in your mind. It's very important, right? We're gonna come to it. So it's a broadcast that will be broadcasted in the network, looking for any DHCP server, any help, right? If there is a DHCP, he's going to receive that broadcast. He will send back an offer saying, hey, don't freak out. I'm here. I'm going to help. I'm a DHCP, and I have this and this and this configuration for you. If you will accept it, tell me, right? So we will tell him, okay, I can give you the address 192.168, something like that. Of course, from the range, from the scope, we have here scope already configured, and so on. But this is block one, right? We studied this in block one, the process, how it happened. So this guy, if he gonna accept it, he will send a request, like an official request for that configuration. He's gonna tell you, okay, I want this address, please give me that address, right? Give me that whatever configuration. It's not just an address. We can configure a default gateway, a DNS, whatever was in that offer. He will request it, like, officially. Okay, please give me that. And after we have an acknowledgement, this guy like signing a contract in between and saying, okay, I'm gonna give you this for 8 days, or it depends. It depends on the lease how was configured. I'm gonna tell him, okay, I'm gonna borrow this, your configuration, now it's yours, right? Please sign the contract between us, and I will get back to you on 8 days, see if you still need it, so I'm gonna give it to you again, or if you don't need it anymore, I'm gonna stop the lease in between. All right, so we have this 4 processes starting between a broadcast. Okay, so it's just a review. We're gonna come back to it. Now let's talk about the static routing on the servers, how they work. So if I have here a server or any machine, and I'm gonna have the first network here. So this is a switch. Let's call this one, for example, MTL. So this one is MTL, and let's say this one is 192.168.0.0/24. It's just a class C, a regular one, and then we'll have another Windows 2022 or 19 or whatever. That's gonna go to another switch here, right? And another one router here, and let's say, for example, another router. Why not? We can add a lot here, right? And well, here I forget the switch, so let's put some switch in between. Okay, and let's make it simple. Let's say this switch is S1, and this one is S2, and this one is S3. And here I'm gonna have another switch here, S4. And I will have a client or a computer, this is Windows 10 or server or whatever, machines here. I have machines, and this one is S4, right? This one is the S4. Let's say S2 is 10.0.0.0/8. I can have subnets also, right? I can have subnets, but since we are learning the logic behind, so I will avoid the subnets for now. I will just take a regular class full networks we're gonna do those example with. Subnets now, once you get the configuration and the logic behind, and after you can play with whatever addresses you have. Okay, let's say this one is 40.0.0.0/8 again, and this one gonna be, for example, 30.0.0.0/24. All right. Okay, so this is a classless here. Class A with the subnet mask of third or class C. This is my S1. This is server one, right? This is R1 for router one. This is R2 for router two, and this is R3 for router three. Cool. But what we can do here, we can do it a little bit better. So I'm gonna make it a little bit smaller here. So this is my server. All right, and here. Make it a little bit bigger. And this is my last switch here. And this is gonna be my computer Windows 10. Now we can have this topology like this. Okay, perfect. Much better. All right, and this one gonna be S4. And we said that it's 30.0.0.0/24. Cool. Don't mind to ask questions, right? Stop me and ask questions if you are lost or you don't know what I'm doing, or you forget what I'm talking about, or you forget what is a router, for example. Right? Okay, so I have a server here. I have R1, R2, R3, three machines that, by the way, I'm installing here, right? So I started installing this morning. They should already finished or almost, right? So I will just configure the administrator password. And so I have R1 and R2 and R3 here. I started earlier this morning installing those machines. Okay, let's say that we're going to distribute some addresses. Let's say the address of the server is going to be 192.168 and 0 and 1, right here. Of course, subnet mask. So this is IP. And subnet mask gonna be 255.255/24, right? 255. dot 0. Okay, and I will have some address here. So the address that's going to be here, I'm going to take, for example, I'm going to separate stuff here. So this one is going to be 192.168.0.100, for example, right? So IP R1, and the subnet mask will be 255.255.255.0. So this one is R1 S1, right? And let's name them like that. It's going to be much more easier for us after to play with. So I'm going to call it R1 S1. So you see it's on R1, but it's on zone S1, right? R1 S1. Remember, the router have two cards, right? You have one in S1 and one in S2. And let's say this one is going to be RS2, and I will just put it here. Let's say this one will be S2, and it's a 10.0.0.0/8, and I will put the configuration of the other card on top, right? So here we go. So this one will be R1 S2, and it will be 10.0.0.100, for example, right? And subnet mask will be 255.0.0.0/8. Okay, cool. Let's keep going. I'm gonna have R2 S2. So you see here the side of R2 S2. Okay, and let's do this. So R2 S2 will be 10.0.0.200, for example, right? Remember, well, S2, this is the network the network ID. R1 S1 already took the 100. The one that is next to it is going to be, for example, 200 or 2 or whatever, something in the same network. So for better organization, I'm going to take 100, 200, 100, 200, right, to make things easier for me also. 10.0.0.200, and subnet mask, of course, gonna be 255.0.0.0. Cool. I will have another card, so I'm gonna put here S3, and S3 is 40.0.0.0/8. So here I will have R2 S3. You're not confused, right? You keep following me? Everybody? You good? I'm just distributing IPs over my topology. That's what I'm doing, okay? So this one gonna be R2 S3 here. R2 S3. That will be a 40, for example, .0.0.100 now in this side, and the other will be 40.200 here on the R3, right? And the subnet mask will be 255.0.0.0. It's a /8. Good. One last router here. Now we're going to distribute some addresses. So this one will be R3 S3. You see, it's on the side of S3 here, this card. So it's going to be R3 S3. And the IP address is going to be 40.0.0.200. Remember, I take 100, 200, 100, 200. So it's going to be 40.0.0.200. And the subnet mask will be 255, it's /8, right? 0.0.0. And I have a last one here. So here it's S4. and it's 30.0.0.0, but /24 here, so I need to be careful with the subnet mask. And on top here, it's R3S4. So it's on router 3, the card is on router 3, the side S4 of switch, and it will be 30.0.0.100, okay? And the subnet mask will be 30, sorry, 255, and be careful, it's /24 here, so it's 255.0. Perfect, good. Okay, I can give also a little IP here for my client. So my client will be 30.0.0.1, and the subnet mask is 255.255.255.0. Subnet mask as IP, sorry, here. Oops, it's gone. All right. So it's gonna be 30. Okay, so this one is IP client and subnet mask client. Okay. All right. Anybody have any question till here, or are you confused by something? It's nothing. I did nothing. I just configured the IP addresses. I have 4 switches. See, S1, S2, S3, S4, and I have 4 networks. This is my first network ID. This is my second network ID, third and fourth. And I distributed some addresses in the side of each router. Any question before going forward? Any question? Everything good. Okay. Nice profile pictures. Well, thank you. Thank you. I photoshopped it. I'm not that handsome, so. I'm just kidding. In real life, I'm more handsome than that. Thanks. All right, so let's keep going here. Okay, we have S1, S2, S3, S4, and it's wonderful because we don't have any questions, so everybody know what I'm doing till now, of course. Okay. All right. Now, if I do this configuration like this, right? I would change nothing. It's just like this. I put in the addresses. Could I ping from the client to the server? Come on, make me happy. Tell me the right answer. Could I ping from this client here? That is Windows 10, by the way, here, for example. He will get to see your building one day, maybe, after COVID. Come on, people. Windows 10 here. Can he ping the server? Come on, wake up. It's almost 9 o'clock. Come on. Could he ping it or not? Come on, dead people, come back to life. We are on Earth in the 29th January 2022. We are alive and we're studying. Come on, need to put roots. Well, I didn't ask what we need or not. Could he ping or not? So if I take the CMD in Windows 10 and we'll try to ping 192.168.0.1 from here, from the CMD of this guy here, could I ping it? No, of course no. Of course no. Remember, we can ping computers that they don't belong to the same network ID, right? Computer talk to the same family. Well, different switches can ping. It's not because of just the different switches. It's because of the configuration also that is completely different. This one belongs to this family, so he can ping the computers that have the network ID 30.0.0.0/24. Okay. Right. It's not just because of the switches. It's because of the switches also, but the configuration also is completely completely different, right? So we have different network IDs that they can't talk to each others. Different network IDs that they can talk to each others at all. So to be able to talk to each others, we need a routers in between. Cool. Is something confusing about what I just said? To be able to ping each others, we need a router in between. Okay, I put it router. Isn't those routers? R1, R2, R3? They are routers. So why logically they will still not ping? Default gateway. Yeah, sure. This is the first thing. Of course, my clients here need a default gateway to be able to use the router service, because this guy here, he don't know that R3 is a router that can help him to send packets over this direction, right? So we need to configure his default gateway, telling him, hey, we have a delivery service here that can help you to deliver your packets if you are talking with anything in this side. And his address is 430. See, here's it. So the one that is in this side here. So this is the default gateway. So it's 30.0.0.100. So I need to configure a default gateway in this side. Good, perfect. Okay, good answer. The one that he said, Toyesh. Okay, so firewalls down, of course. Just let's take this like by default. Everything is down as firewalls everywhere. All right, but good for a reminder. Of course, guys, here firewalls are all down. Okay, so I need to tell this Windows 10 here that you have a delivery service that you can talk to if you need to talk with people that they are not in your family. All right, because he can talk to others that they don't have this network ID here. Okay, but we're gonna by putting this default gateway, we're gonna tell him we have a delivery service. If you need to deliver something, to send something that someone that doesn't belong to your family, well, send it to this post office and they will take care about it, right? So they're gonna take care about all the process of the delivery. Okay, they have trucks, they have planes. It's kind of DHL or FedEx here. So we are giving him the address of FedEx that it's in his area. You see, it's in the same network ID 100, and this one is 1. So he can communicate with this one without using post office, and he will be able to send those packets over this service, this delivery service. Okay, cool. And it's the same thing here, because this one need to ping this one, or even if he's pinged, he need to send back an answer. So this guy, he don't know that R1 can help him, right? He don't know that R1 is the one that handled the delivery service for this area. So we need to give him the address of that post office or DHL office where he can send his packets to talk to people that they are different than his network ID. Okay, so this network ID is 00 here, but if you talk with the others here, he don't know that there is a delivery service that can help him to do that. So we will point this R1 default gateway here. So this one, S1 R1, the 0100, will be a default gateway. Sorry, not SM here, DG. So the default gateway of this client will be 192.168.0.100. Cool. So now server 1 can use the delivery system, and server and Windows 10 here, he can use the delivery system. So they know to who they need to talk if they need to deliver the packets to other people, right? Good. And Davinder say here, need to forward the route of IP to router 3. Develop this. Okay, so I'm gonna tell you quickly here, even if we do the default gateway, it's still not work. We are missing a lot of things here. One thing, Davinder is saying need to forward the routes of IP 000 here, so this area, He said that we need to deliver them to router 3. You are in good direction, but you're still just on the beginning of the logic here. But good starting. He said that we need to deliver. Yeah, isn't it the work of router 1 to do that? So what I'm missing here. One more time, Davinder said that we need to deliver or forward the packets from this area to router 3 to be able to reach Windows 10 here. But it's a job of router 1. Is he qualified to do that? Look at his configuration. Is he qualified to do that? Or we're still missing a lot of things here? Come on, think about it. Come on. He needed next default gateway. You are so close, Jaskaran. Jaskaran said that R1 need the next default gateway. Interesting. A very interesting sentence that he said here. He need next default gateway. So if I come here and configure the default gateway of this card of R1S2 as 10.0.0.200, you think that it's enough, Jaskaran? You think that it's enough? Come on. Come on, don't stare at your camera for nothing. Come on, think about it. Move your neurons. Move your brain. Come on. Process. Help me here. I need help. In the meantime, I would just log on here. Come on, think about it, right? I'm just logging here. Password, sorry. Come on, anybody have any clue? No idea? Well, at least, even if it's wrong, but at least I was expecting from someone to tell me that R2 need to have the default gateway, the other one, right? So it should work always in two ways, okay? So this is what I was expecting, even if it's wrong, right? So we're gonna come back to this, but this, at least I was expecting someone telling me that I need to put here 10.0.0.100. Logically, if we did put the default gateway this one, so he need to know what is next door. But the packets when they come this way, so R2 need to know what is the next door also, right? What is the next default gateway? So at least I was expecting someone telling me this, but shame on you, you're sleeping. Wake up, people, wake up. Okay. And it's the same thing now. If I go to this card here, I'm gonna, well, this one shouldn't be here. This one should be here, right? Default gateway in this card. So it should be the 10.0.0.200. And this one 100 point in this one. So I should do the same thing here, right? I think. So I would take the default gateway here and I would put the 40.0.0.200 pointing to the default gateway here. And this one I will point it here also. So this one gonna have a default gateway 0.0.0.100. Well, at least if you were crazy, but logically crazy, this is what you should have told me to do, right? And if you do this, it's gonna work till here. Over 2 routers, this configuration is completely correct over 2 routers. But here the packet's gonna be messed up in Microsoft environment. It will not work over two default gateways, more than 2 default gateways. So if I take Windows 10 and I will plug it in S3 here, my Windows 10, and I will give him an address on 40, and I will cross over the default gateways between these 2 routers, I will be able to ping the server. It's gonna work till here, the limit, right? But if I extend it to more other servers here, this configuration is useless, so it's still wrong. What about if I'm gonna have like a lot of routers? I will not be playing with default gateways in between the routers like this. Okay, but at least if you told me that, I would have been proud of you, because at least you tried and you had some logic behind. And nobody said that, but just Karan, at least he leaded us up about this default gateway, at least the minimum. Okay. Well, we have a solution for that. The solution is, look at here. So this guy, he knows R1, right? He knows that R1 work in DHL or FedEx or whatever, right? So he know that if he send him, this guy work in the delivery service, so he can deliver wherever it is. Okay, so this portion here is good. And this guy also, if he had to answer, for example, to stranger, or if he had to initiate the communication with other strangers, he know what is the office, the post office that he gonna send, or the delivery service. He know the address, his default gateway. But the problem here that we have something wrong in our delivery system. The delivery system between all the routers here is missing a lot of information. R1, he don't know that the 40 exists, and he don't know how to get there. He don't know that the 30 exists, and he don't know how to get there. Like, for example, imagine R1 is an office in Canada here, right? So an office in Canada, we have borders with the United States, and we have borders in the north with Russia in the North Pole, right? So it's 2 countries. So we can see Russia and we can see United States. That's it, right? But we don't know that Brazil exists, for example. We don't know that India exists in Canada here, because we don't have borders with them, right? So we don't know that those countries exist at all. Okay, so to be able to open a delivery that gonna goes to those countries, we need to come to the delivery system of Canada and teach him that there is a country named Brazil, that it's 40,000, and we need to teach him how to go there. And we're gonna need to teach him also that there is a country named India, and we need to teach him how to go there. Because the only other 2 countries that he know about this R1 is United States, that it's his border, and Russia on the Pole North, on the North Pole, or Finland or something, the people that they are all sharing the Pole North, right, the North Pole. So he belongs to these 2 networks. You see, we don't need to tell him that 10.0.0.0 exists, because He has a card in there. He know them. He know those guys. Right? He work with them. He's one of them. He have even an identity in there. This is it. 10.0.0.100. We don't need to tell him that S1 exists because he belongs to S1. He has a side on S1. But the problem with R1, to do his job, he need to know that S3 exists somewhere because he can see it. He don't know it, right? He don't know that as, how the hell he gonna know that S3 exists? He's not connected to S3 at all. He don't have any link, any card that belong to this network, right? And this is where come static root. First, here's where come routing in general, right? But routing is divided to two type of routes. We have static and we have dynamic. And the dynamic is not configured in or covered in this module. We're gonna do it on module 4. The next one, right? Next one will be all dynamic, REAP, EGRP, OSPF, and stuff, BGP, and so on. And we're going to see how the difference between them and how the configuration between them. So in our class today, it's not dynamic. We're going to learn this static root, right? So we're going to need to use whatever magic to come here in R1 and tell him that, hey, there is a far land from here that you don't know that it exists, that it's El Dorado, full of gold in there, something. So this is the map, how to go there. I'm going to give you the instruction of navigation to go tell that land, right? And I'm going to tell him there is much more than that. There is another land also. It's the 30,000 that you can see. It's far from you, right? But I'm going to teach you how to go there, right? And this is exactly the way that we're going to configure our static route. So we're going to come here on R1 and we're going to configure stat 1. It's for S3. So we're going to see what R1 can see. What R1 can see. Come on. This is an easy question. Help me. What R1 can see. What he can see. Which switches? Come on, guys. Come on, or I will turn off the meeting and go sleep, right? Come on, help. So he sees S1 and S2. Good. Davinder said, Mansi said R2, S2. Nope. He see S1 and S2, Mansi. Good try, but it's not really R2 or which switches he see. This is why I asked. Which switches he see? He see S1 and S2. You see R1, he can see S1, the area S1, and he can see the area S2. True or not? Which network ID he can see, or which S's he can see, which network he can see. He can see S1 and he can see S2. Okay, those are the ones that he can see. Right? Toyesh, Jaskaran, that's correct, right? So he can see S1 and S2. Everybody agree here? Everybody agree? Cool. Okay, so R1 can see S1 and S2. I don't need to teach him how to go there. I need to show him what he can see, Which network he's not able to see. Shiv saying S3, S4, Jaskaran S3. Is just S3 that he can see, Jaskaran? What about S4? Come on. S4 also is far from him, right? Yeah, S4 as well. Okay, so he's not able to see S3 and S4. So the static routes that I'm going to configure here, they're going to be 2. I'm going to teach him how to go to S3, and I'm going to teach him how to go to S4. So I will configure here static route. First one is for S3, and I will tell him to send to S3, where he going to send his packets. You see, we are here in this router, and we want to go to this direction, to S3, we need to send to the next door, right? The next hop, or the next node. The next node is the card of R2 S2 here, right? So we need to send to 10.0.0.200. Okay. And we're gonna teach him also how to go to S4. So we're gonna tell him, hey, if you want to go to S4, where you're gonna send to go to S4? Where we're gonna send? What is his next door? If you want to send from here to this direction to go to S4, what's gonna be the IP address? 40? Can he see 40? Gurpreet said 40.0.0.200. This is smart and good, right? But logically, think about it. Can he see it? Just Karan said the same. Yeah, of course, it's the same. So you see, Gurpreet, focus with me, right? We are here, and we want to send to whatever is in this direction. We don't care where, right? Whatever in this direction. So his friend who's gonna take care about that, he's gonna be always this door of R2, right? So imagine if you are in a building, and those, okay, let's say this is housing, right? This is housing, and you are in this classroom where you're gonna have a door here. Okay, so you have a door here, right? An open door here, and this is C1, classroom 1, right? And this classroom 1 gonna take you to classroom 2, and you have another door here, right? Okay, and you, this is Gurpreet. I'm gonna try to make you really beautiful here. Here we go. All right. Well, some hair, right? Let's say here's it. Better, much better, and smiley face. Okay, and you are here. You're here, right? In C1, and this is a door that's gonna take you just to C2, and after on C2, you're gonna have here another class with another door that's gonna lead you to another class, for example, with another door. So this one is another door here, and I have another door, so I can go this way, right? So this is the other door, and this is C3, and this is C4, right? And this is C5, and after I'm gonna get till C6, right? Okay, and you are here, right? Go ahead, you are here, and I'm gonna tell you, okay, so C1, if you want to go to C2, which door are you gonna take? You don't have a choice, right? It's this one, the next to you, right? So you need to jump from this classroom to C2 over this door, right? Okay. If you are here and I'm gonna tell you go to C6, which door are you gonna take? Directly this one? Are you able to take this door from here? It's impossible, right? You need to go over the first door. So D1 here and D2, and so go on. But for you, if I configure your brain and I will tell you go to C6, which door are you gonna use the first one? D1, right? Because from here, you don't even know D2 yet. You don't even know door 3 or either door 4 or either door 5. You don't know them yet. You are right in C1, and the only door you know for now is door 1. Can we break the wall between rooms by any chance and go straight? Well, there is here Mr. Paji and Tao. I think that they're gonna do bad things to you if you break the wall here. You're gonna pay for it, and it will be you You will be to prison, right? Jail, something like that. If the best thing that you will go over with it, if you break the wall, maybe you will be retained in some medical facility because you're gonna be crazy. It's gonna be better than the jail. But this is the best one. My bad, sir. Why? It's not your bad at all. It's good. It's good try, right? I'm just explaining to you. Well, at least I try. You try and give me wrong answers, then just staring at me and right. It's gonna be really boring. So, but it's good. It's good. It's good. Good. You tried, and it's good answer, right? So I hope you get the logic behind this, right? So as for now, it's exactly the same thing, right? So you are here and you want to go here, but the next door for you is just 10, 0, 0, 200. So you need to send to 10, 0, 0, 200. It's the same. You need to send your packet to the next door right here. Okay? Everybody is good with this? Trying is more important, of course, of course, of course. At least you try. And it's more important for me also. At least there's an interaction so I will not sleep. Okay, everybody get it here for static one, for router one? Everybody get it? No confusion, nothing? We're good? Okay, now since you get it, is it enough? Is it enough? No, I need to configure router 2 now, right? So what is the configuration of router 2? Same thing, same logic. What he can see, what he can see. So you always ask yourself this question. What router 2 is able to see, what he's not able to don't see. And the thing that he can see, we need to teach him how to go there. That's it. This is static route. If you get this, the answer to this question, you know how to configure it. So just gonna say he see S2, S3. Good, good. You see router 2 is connected directly to S2 and he's connected directly to S3. So I don't need to teach him to go there. He belongs to these two families, right? He belongs to these two families. He already have a network card in each network in each side. We're good with this, okay? Now, if I'm gonna configure static 2 here for router 2, stat 2, what I'm gonna configure for him and how I'm gonna show him how to go there. So to do that, I need to answer the question, what he is not able to see, what he can see. Come on, R2, what he can see. Come on, guys. Mansi saying S1, S4. Just Karan is not just S4. Can he see S1? No, S1 as well, right? So it's the second time that you are forgetting the network. Huh? Yeah, before here you told me S3 and you just S3 and S4. What about S4? Okay, some consideration to S4, please. Okay, same thing here, R2, please consider S1. Give him a chance. Right? He wants to exist also. He wants to talk and he wants to contribute to the network. Right? So don't ignore him, right? So Shiv saying S1, S4. You see? Shiv, he got it better than you. At least he considered S1. The R2 here, he need to talk with S1 and S4. So we need to teach him that these two networks exist and we need to show him how to go there. Okay, so let's see the first one. We said the first one is S1. So we need to configure a static route from R2 to S1 and over what he can go there. What's gonna be the door? What's gonna be the door? Come on, Gurpreet. It's for you this question. We break the wall. As said, or I forget who said that. What's gonna be the door to go from R2? We want to go to S1. You see, we want to go to this direction now. From R2, we want to hit this way. What's gonna be the next door? .10.0.0.100. Congratulations. Yeah, it's that one. So she said that we need to send from here to the door that is next to it, right? We want to go to this direction, so we need to send to 10, 0, 0, 100, and it's exactly that one. It's correct. Now, what if I want to send to S4? See, from R2, I want to send to S4. What's gonna be the gateway? $40. We want to go to this direction. It's correct, just Quran. Good. Come on, Gurpreet. Come on, I'm waiting for your answer. Where I'm gonna send here? S4. Yes. So it's where is 14100? Where's 14100? You said 40.0.0.100. Where is it? I'm here, I'm on R2, and I want to go to this direction. What's gonna be the gateway? Be careful, the 100 is itself. It's on R2, so I don't need to send to 100. I need to send to 200. It's the one that is the next, right? So here, it's 40.0.0.200. Good. Be careful, right? It's not the 100. The 100, it's the one that I'm configuring, by the way. Right? The 40.100 is the one that I'm configuring this static root on it. So I'm unconfiguring this one inside this. Okay. Or we can just say that's just kind of sad. He said that we're gonna send it to R3 S3. This is it, R3 S3. Right. So we're gonna send it here to go to S4 from R2 to go to S4. We're gonna send it to R3 S3. Okay, good. Still missing something to make everything work here, but almost done. I still have one last router that he don't know the existence of everything here. Okay, what I'm gonna do in R3, come on, this one should be very easy now for you. First of all, I need to ask myself what R3 can see, what R3 can't see. And after, I will know what I have to configure. Okay, so what I have to configure here in stat3, what is my stat3? Come on, everybody try. What is stat3? Good, Chief, good. And what it can see, Just Koran? What is missing? Okay, well, at least you give me two now. Okay. I was waiting for one, right? I would have kicked you out from the meeting. Good. Mansi saying S4. No, Mansi. I'm not asking yet for any IP address. I don't know what you meant by that IP address, but I'm asking what R3 can see, what he can see first, to be able to know what I'm gonna configure. Okay. Come on, the other Davinder, Tarampreet, wake up. Rajvansh, Ankush, Janish, belong to this class also, right? Wake up. What he can see, what R3 can see, what he's not able to communicate with. Good, Davinder, good. R2 S3, Rajvansh, no. What he can see, what he is not able to see, which networks R3 is not able to see? Simple question. Are here on R3 what he is not able to see? Tarampreet, good answer. Mansi, good. Toyesh, good. All right, so almost everybody here said It both goes via. Yeah, it's correct, Davinder. Good. S2. Yeah, just Karan. It's exact. Okay, so R3 is here. What he's connected to? He's connected to S3. You see that he had a card on S3 and he has a card on S4. So those guys are his friends, right? He see them. He live with them. Is his home, his environment. But he don't know about the existence of S2 and S1. You see, they are far from him. He's not connected to those guys. He don't know them. So we need to teach him how to go there and how to talk to those guys. Okay, S3 and S4, he belonged to those two area, S3 and S4. He can talk to them. He know them. We don't need to configure anything. He already have a card in there. You see, S3, here you go. And he has another card on S4. So he already know how to talk with S4 and he already know how to talk with S3. So we need to teach him how to go to S1 and S2. And we're gonna do here, for example, S1 first. If he want to go to S1, he's on R3 and he want to go on this direction, what's gonna be the next card? What's gonna be the next door for him? So if we are on R3 and we want to go on this direction to go to S1 here, what's gonna be the card? And many students already answered 40.0.0.100. Good, Mansi, right? So here it's gonna be just the next one. Got it, Gurpreet? Again, it's the next door, right? Okay, so it's gonna be 40.0.0.100. And if I want to go to S2 from R3, I want to go to S2, I need to show him the way. What's gonna be the next door? From R3, I want to go to this direction to S2. Same, good. It's gonna be exactly the same, 40.0.0.100. All right, now if I configure all my routers with this configuration, trust me, this guy will be able to talk with this guy without any problem because he know what is the delivery service. So he's gonna send packets to R3 and R3. So I'm pinging this server, right? Something in the 192 and R3, he know that the 192 is S1, so here is it, and he know that he need to send it to the 40.0.0.100. So he will just push it back to R2. If you want to talk to S1, so this one is pinging S1, right? The client is pinging S1. He will just send to the delivery service. He know the address. Okay, path, he will send it to the delivery service. R3 will save the packet that he need to deliver to S1, and he know how to go there. So we told him, if you have something to deliver to S1, just send it to 40.0.0.100, and he will send it to R2. R2 will open the packet, and he will see that the destination is S1, right? Okay, S1, I know where to send it. So he's gonna send it to 10.0.0.100. Puff, he will send it here, 10.0.0.100. R1 will save the packet, he will open it and he will see the destination is S1. Okay, I know these guys. There you go. And he will look for the MAC address of the server that have the address 1 that this guy pinged, and he will deliver the packet to him, right? And same thing for the answer. Now, after the answer, will work exactly with the same principle. So server need to answer an ECMP request to the Windows 10 saying that, hey, TTL 128, I received your packet, sir, right? So what he gonna do? He's gonna switch the address of the packets to 30.0.0.1, so he will talk with S4, right? And he will send it to S4. S4, it doesn't belong to his family, so he need a delivery system. Oh, thank God, he already know the address of the delivery system, so he will send the packet to the delivery system. R1 will open up the packet. He will find the address should go to S4. S4, he don't know them, but he already have a map or instructions how to go there. So he will open the packet. He will see the destination is S4. He will not care about it. He will see that, okay, S4, I need to send it to 10.0.0.200. He will close the packet back and he will send it to 10 .0.0.200 here. R2 gonna receive the packet. He will open up. He will see the destination. Ah, it's S4. I know how to go there, right? He will close it back and send it to 40.0.0.200. Whoop, it's gonna go here. This is 40.0.0.200. R3, he will open up the packet. He will see, the destination is S4. Okay, it's just my home here. I know those guys. I have the card and I have the MAC address of the computer. He will see the address that it's 01 on S4, and he will send it to the client. And we will see in our screen TTL 128, 128, 128. So he will send 4 packets, and he will receive back 4 packets, right? 4 answers. Okay. So this is how things work with the static. All right. Static routing, you know, in each router we have something called a routing table. A routing table gonna have destinations, destination 1, for example, and the gate to that destination, and destination 2 and the gate to that destination, destination 3 and the gate to that, right? So this is the routing table. The routing table is the map, the treasure map of the router. And every time that he's gonna need to go somewhere, he will check on his routing table to see how to go to that destination, right? In the static route, this routing table is configured statically, isn't it? This is what we were doing. We were going to router 1. We're going to router 1, and we were putting those instructions manually, and they are static. They never change, right? So this is a static route because we are putting those information by ourselves in there, in the routing table of that router. And this is another routing table of this router here. And we came here and we added those instructions inside. And same thing here. We came on this routing table of this router and we did add the instructions manually here, right? Manually, and they are static. So we configured routing table statically. When you configure routing table statically, like we did like this is a static route. In the other hand, dynamic that we're going to see in module 4, by the way, so this is where we're going to study many different protocols of dynamic protocol. The dynamic protocol, we're gonna tell R1, please tell the others what you can see, right? So it's the reverse of the static. And R1, he can tell R2 and R3, he will just send broadcast packets everywhere saying that he will keep yelling, I see S1, I see S2, I see S1, I see S2, I see S1, I see S2. And the others gonna hear that, okay, R1 can see S1, S2. So they're gonna change dynamically the routing table. They will take, S1, I will send it to R1. And this guy also, he will yell on the network, even the information that he learned from his neighbors. So everybody gonna tell his neighbors what he learned from his neighbors, and they will all auto-configure themselves, right? If there's any changes, they will change it by themselves. This is dynamic. We are not configuring static path or static way to go from somewhere to somewhere, right? But it's not our topic. I just talked about it, right? Briefly today, and in this module, static route. We are talking about configuring the routing table of each router manually, statically, right? We're not dealing with dynamic yet. And route print is the command that show the routing tables in the machines, right? We learned this in module 4, block 1, route print, remember? So route print is the command that show us the configuration inside, and we're gonna check our configurations before and after the configuration to see the differences between what happened in the routing table in each router, okay? Does anybody have any question before we go to the configuration of our routers? So we're going to configure this together. We will try to build up all this together, right? in virtual machines. If anybody is still confused about something or whatever before going there, please ask your questions. Okay. If anybody is still uncomfortable with something here or have any suggestion or didn't understand something here, let me know. So next step is configuring the machines, and we will try to ping from one to another. Of course, I will rename my machines. I will disable firewalls. I will do nothing yet here, but some basic configuration in each one. And by the way, I'm gonna turn on another machine here that I'm gonna use. For example, we use a server from our last labs. Let's take PDCX1 here. Okay, I'm gonna turn this one. We don't care. It's not a condition that we're gonna have a domain here, right? So I'm just using the server, and I don't want to install a fourth one and waste my time. I already have all the servers. And yeah, let's take, for example, the client here. This prep one here. So I have a client, I have a server, and in the middle I have R1, and after I have R2, and after I have R3. You see how things start making sense here? Here we go. Here we go. There's it. It looked like exactly our topology, isn't it? So I have a server, I have R1, I have R2, I have R3, and this is my client Windows 10. Okay. So I will try to ping from this prep to this server over passing the packets over these three routers. Of course, there's a lot of configuration to do, and we're gonna do it all together. We will not be lost because we already have a good topology here. We already made everything ready in front of us. It's just the switches that I'm gonna use others here. It's gonna be Montreal. Here it's gonna be, for example, Tokyo, and this one will be Moscow. I don't want to create all the switches because I already have some switches named over the cities names, and this is what I'm gonna do. Query one here. So this one is R3. Okay, so this is my client. This is my router 3 almost booted. R2 also almost booted. R1 also almost booted. And well, first of all, I will disable firewalls everywhere. We'll rename my computers, right? The NetBIOS names, I will change that. I will add network cards because each router have two network cards, remember? Is it? So R1 have two network cards, R2 two network cards, and R3 two network cards. I will rename the network cards so I will not be confused. It's very important. I don't want to make any mistake. So the card that belonged to Montreal, I will name it Montreal. I will give it a static address, and then we'll go to the next one by one, taking my time. I don't want to crisscross the network cards with the wrong switches, and after I will just create problems for myself that I will spend a long time to try to troubleshoot. We have a merge here that is blocking everything. This is why everything was being slow. Okay. Okay, almost there. Let's start this one. So again, I will configure all the IP addresses with the changing the computer names, disabling the firewalls everywhere. And after, at once, I will configure all my static routes, right? So I will let the static routes at the end. But first of all, I will get all my machines ready. Like here, I will disable the administrator account. I will rename all my computers, restart all my computers. So by the way, it's almost the break time. So I will rename all the computers and start over all the computers, rebooting them, and we will take our break. After the break, they will should all get ready. Okay. All right. Local server. Normal controllers taking a long time to move. Okay, so let's do little changes here. So S1 become MTL Montreal, and S2, well, let's name them differently on top of it, right? So this one become Montreal. And what is the switches that I'm having? I don't remember the names. I have Tokyo, London, I guess. Yeah, so Montreal, Tokyo, London, Moscow, Rio, Paris. Yeah, wonderful cities. We're gonna work with this. Instead of creating S1, S2, S3, already have many switches. This one gonna be Tokyo. This one gonna be Rio. And this one gonna be London. Right? That's it. So S1 become Montreal. Every time that I'm gonna see S1, I will configure Montreal. Every time I'm gonna see S2, like here, for example, I'm gonna configure where's S2? Yeah, here. So every time I'm gonna see S2, I'm gonna configure Tokyo. Every time I'm gonna see S4, I'm gonna configure London, like here and here, for example. And S3 here, I will configure you for it. That's it. Okay, so R1 belong to Montreal and Tokyo, right? So I will have two network cards in this one setting, and I will connect the first one here to Montreal. And this is how the process I'm gonna do it. I'm gonna do it one by one because I don't want to I don't want to be confused with the network cards. So I will connect the first one. I will name it first. So this one is Montreal to be sure, right? Here we go. And after I will add the second one and I will name it Tokyo. So doing this process one by one, I will not confuse my cards or switch them over, right? So I will put the address of Montreal in the Tokyo and the address of Tokyo in Montreal, and it's gonna be completely wrong. Okay, so this one gonna be Tokyo now, and we're good. Here is Tokyo. Okay, I'm gonna disable the firewall. And I will log on here. So this is gonna be off and off and off. Right. And also, since I have a domain controller here, I don't want to change my IP. So hopefully it's the 192.168 something. Otherwise, we're gonna just we're gonna use the network ID of Montreal, the network ID that I'm having in this BDC. It's better, right? just to avoid to install another machine and another server. So I don't know what is the IP here. Local server 1724 100 something. Okay. And is connected to Montreal. Okay. So I will just change here the first network to I don't know if it's /16 or / something. Let's see. Yeah, /24. So it's 172.24.100. All right. So I will just change this portion of network here to 172. So this one will be 172.24.100.0/24. So here I already have 172.24.101, and this one will be 172.24.100.100. That's it. Okay, so the only changes that I'm gonna do is in this one here. So I will be able to use my old machine PDCX, right? Okay, okay. So here's my address one, and I'm gonna need a default gateway, by the way, now here. So let's do it from now. It's gonna be 172.168.100.100. Remember? No, 24 here. Sorry. All right. Okay, and let's configure the address that we put it on the default gateway now in Montreal here. So Montreal become that address that it's a default gateway of my server. So this one will be 172.24.100.100 255 255 255. Be careful, it's /24. All right. Okay, and the Tokyo side of R1. So here's R1 and here's Tokyo, right? So it's gonna be 10.0.0.100/8. So this one gonna be 10.0.0 10.0.0.100/8. Okay, good. Now I can see my configuration here. Firewall is off, and Montreal is 172.24.100.100. Here's it. Okay. So see Montreal in R1 is 172.24.100.100. And Tokyo in R1 is 10.0.0.100. And here's it. Tokyo. I will just change this one to R1 now, and I will restore this machine. So this one will be named R1. Right, close, restore. There you go. R1 will be ready. All that he's gonna miss now is the static routes, and I will do exactly the same thing now on R2. And let's go to R2 and configure R2 step by step. So this is R3. Here's my R2. All right, starting with the firewall here and going to this card. So this first card of R2 gonna be connected to Tokyo. And it will have the address 10.0.0.200. Remember, I'm here now. I'm on R2. and I will have one card on Tokyo and one card on Rio. So let's name the first card Tokyo. So this one should be named Tokyo and should have the address 10.0.0.200. Come on, dude, come on. Here we go. So this one is Tokyo. So we start named it Tokyo before even adding the other one. So I will not be confused between the two cards. And there's no chance that I reverse them, right? So doing things step by step is always better for you. So we'll not do any mistake. Just disabling the firewall in the meantime here. Off and off and off. Apply. Okay. And close. Now I will add the second card. And the second card will be named Ryu. And it will be connected to Ryu switch. Here we go. See, I have the card pop up now, and there's no chance that I'm gonna reverse them. So I know this one is really connected to the switch Ryu. This one will have the address 10.0.0.200, 10.0.0.200/8. I'm good with the subnet mask here. It's good. And the Rio one, let's see what is the IP address that it should have here. So R2 in Rio should have 40.0.0.100/8. Okay, so this one will be 40.0.0.100. See, I'm doing things step by step. I will not make any mistake or reverse any card or something. Okay, I will minimize the chances. I still can do mistakes, but I'm trying to minimize all the chances here. Okay, so my firewall is off. My two cards are configured, and all I need is to change the name here to R2 and restart this machine. And I will jump to R3, and after we're going to take a break, right? So we're going to do exactly the same things on R3. And we take our break, and after the break, all we have to do is to configure our static routes. Okay, so this is my R3 here, and I will start with the firewall. I will change the connection here. And I will connect. So the first card that should be connected on R3 should be connected on Rio. You see R3 here, it's R3S3. So R3 Rio, R3 Rio here. And it should have the address 40.0.0.200. 40.0.0.200. So I'm going to connect it to Rio. I will rename it here Rio. And now I can add the second one. So the second one will be London. There we go. And I will connect it to London. So this one gonna be London. And London gonna have 30.0.0.100. Remember? Here's it. Let's check it again to be sure. There you go. See, R3 in London, R3 in London is 30.0.0.100. But be careful here, the switch is different, the subnet mask is different, it's class C. So I need to take care about that. It's 30.0.0.100. Oops. 30.0.0.100. And here I need to customize subnet mask, of course, to 255.255.255.0. It's a /24. I'll click OK. OK, close. Here we go. Firewall should be off. And also change the name here. Come on, firewall. And I'm going to do the same thing here. I will enable change the computer name to prep. I will change it to something. And well, I'm going to let this one like this. It's just a client. I will just connect it to London. See here. So I'm going to put it on London. And after I will put the address 30.0.0.1/24, right? Be careful, it's a classless. Here we go. There's different firewall property, output off and off and off, apply, okay. And change the name. It's the last thing that I'm gonna do here. I will change the name to R3 and everything gonna be ready. In the meantime, we're gonna take a little break. If you have any question, please feel free. Otherwise, we're gonna take a little break. Yeah, one is, yeah, of course. But I saw just the season 1. I didn't see the others. What was the crazy guy name? Berlin. Yeah, I loved Berlin. Berlin was my favorite character. Right, crazy one. Well, I hope we're gonna one day make enough money. We started with the lab now, and the easy part is coming, is the money, right? So the hard part, we already did it today, the names. Because it doesn't make sense at all. Well, I hope so. I hope so. I hope that the money is gonna come in soon. All right, guys. If any question, please feel comfortable to ask your questions. So otherwise, we're gonna take a little break here of 30 minutes, catching our breath, drinking some water, right? Changing the idea and coming back to configure our first static route here over 3 routers. We good? No question, nothing. Helsinki. No, I'm not Helsinki. Come on. I'm the professor. I'm professor. I'm teaching you. How you put me Helsinki? I can't be all the things that the professor. Yeah, the beard. I'm gonna shave it soon, just to be the professor. No, look at the statue. Don't look the beards. Come on, you're cheating. My statue is teaching, so I'm the professor. I choose the names of the router. I'm the one who chooses the names, etc., etc. What about you? What are you gonna be? You? You're a cop. You're a cop. I smell a cop on you. Okay, Vandan Kumar. See you guys. See you after the break, right? See you in 30 minutes. I'm gonna notify you on the phone, so keep Kaizala just next to you. And 30 minutes, we're gonna come back here. Everything is going very well. You see, the computers are booting. I will do nothing during the break. Just put in some address in London client here, right? That's it. And disable the firewall in this one, so my client will be ready. See you in 30 minutes, guys. See you in 30 minutes.